So let's now talk about hinge joints. Open and close a door a few times. Observe the hinges of the door carefully. They allow the door to move back and forth. Just like opening the door, you can do open only at one side, right? It will not go other way around. In activity 3, say this kind of the movement allowed by the hinges. Make a cylinder with a cardboard of thick charred paper as shown in the figure 8.5. Attach a small pencil to the cylinder by piercing the cylinder at the center as shown in the figure. And now observe that how does it move. So this kind of the movement is like a hinge movement that only happens at the one side. Now try to recall what type of this kind of movement is there in our body. So obviously the hinge joints of the knees, right, is one such example in our body. But in illustration the directions in which the hinges allows the movement. The elbow has a hinge joint that allows only a back and forth movement. Can you think other examples of such thing? Now fixed joints. Some joints between the bones in our head are different from those we have discussed so far. The bones that cannot move at the joints, such joints are called the fixed joints. Now when you open your mouth wide, you can move your lower jaw away from your head, isn't it? Try to move your upper jaw. Now you are able to move it? Not really, right? So there is a joint between the upper jaw and the rest of the head, which is a fixed joint. So upper jaw is the example of fixed joint. We discuss only some of the joints that connect part of our body. What gives the different parts of the body their different shape? If you wanted to make a doll, what will make it first? Perhaps the framework, to give the doll a shape before making its outer structure, isn't it? So all the bones in our body also do the same work, and they give us a framework to give a shape to our body, which is known as the skeleton. How do we know that this is the shape of the human skeleton? Okay, how do we know the shape of the different bones in our body? So we can have some idea about the shape and numbers of bones in some part of our body by just feeling them. One way we could know this shape better would be to look at the X-ray image of the human body. Did you have anyone in your family ever had an X-ray? You can just look at that X-ray. You will find out that the X-ray shows the bone parts in our body. Sometimes when we hurt or have an accident, doctor use X-ray image to find out about any possible injuries that might have happened to the bones. The X-ray shows the shape of the bones in our bodies. Feel the bones in your forearm, upper arm, lower leg and upper leg. Try to find the number of bones in each part. Similarly, feel the bones of your ankles, knees, joints. Compare these with the X-ray images and try to feel where they are located, and can you find out the joints. Bend your fingers. Are you able to bend them at every joint? How many bones does your middle finger have? Feel the back of your palm. It seems to have many bones, isn't it? So is your wrist flexible? It is made up of several small bones called the carpals. So you need to underline these words, right? That may be asked by your teacher. What will happen if it has only one bones? So there is an activity 4, right? Take a deep breath and hold it for a little while. Feel your chest bone and back bone by gently pressing the middle of the chest and back at the same time. Count as the ribs, right? Bone of the chest. So this is called the rib cage, right? Now observe the figure 8.10 carefully and compare with your feeling the chest bone. We see that the ribs are curiously bent. They join chest bone and the backbone together to form a box. This box is called a rib cage, right? So here's the definition of it. You need to underline them. There are 12 bone ribs on each side of the chest. Some are important. Some important internal parts of our body lie protected inside this cage, and that's what it's a heart, isn't it? Ask some friend to touch their toes without bending their knees, starting from the neck. Move your fingers backward, downward, on the back of your friend. What you feel is known as the backbone, right? So it is made up of as many small bones called the vertebrae. Right? So backbone is made up of the vertebrae. There are 33 vertebrae. The rib cage is a joint to these bones. If the backbone was made up of only one long bone, you are not able to bend, isn't it? Make your friend stand with the both hands pressed to the wall and ask her to push the wall. Do you notice? The two bones on the back are prominent where the shoulders are. They are called the shoulders bone. Now, carefully observe the structure is made of the pelvic bones. They are enclosed the portion of your body below the stomach, this part where you sit on. So the skull is made up of many bones joined together. It encloses and protects a very important part of our body is called the brain. We discussed many bones and the joints of our skeleton. There are some additional parts of the skeleton that are not as hard as the bone, which can be bent. So these are called a cartilage. Do you see the cartilage were found where the location is the ear? If you touch the part of this ear, you will see that it's a little bit harder, but not as hard as the bones. Feel your ear. Do you find any hard bony parts that can be bent? There doesn't seem to be any bones here, isn't it? Do you notice anything different between the ear lobe and the portion above it? So as you press them between the fingers, you do feel something in the upper parts or the ear that is not as soft as the ear lobe, but not as hard as the bone, isn't it? So this is a cartilage. Cartilage is also found in the joints of the body. We may have seen that our skeleton is made up of many bones, joints, and cartilage. You could feel, bend, move many of them. You can draw up neat figures of all skeleton in your notebook. We have learned about the bones in our body and about joints that help us to move in a different ways. What makes the bone move the way they do? Let us find out. Make a fist with the one hand and bend your arms at the elbow and touch your shoulder with the thumb. Do you see any changes in your upper arm? Touch it with the other hand. Do you observe a swallow region in the upper arms? This is called the muscles. The muscles bulge due to contractions. Now bring your arm back to the normal position. What happened to the muscles? Is it still contracted? You can observe similar contractions of muscle in your leg when you walk or run. So the muscles help the bones to move. When contracted, the muscles become shorter, stiffer, and thicker, and it pulls the bone. The muscles work in a pair. When one of them contracts, the bone is pulled in the direction. The other muscles of the pair relax. That's how the movement takes place. To move the bone in the opposite direction, the relaxed muscle contract to pull and the bone towards its original position. While the first relaxed muscle can only pull, it cannot push. Thus, the two muscles have to work together to move the bone. Are muscles and bone always required for the movement? How do we other animals move? So do all other animals have the bones? What about the earthworm or other small snail? Let us study the manner of the movement that the gait of some animals. Gait of animals. Earthworm. Observe an earthworm moving on the soil in the garden. Gently lift it and press on the piece of blotting or a filter paper. Observe its movement. Then place it on a smooth glass plate or any slippery surface. Observe its movement. Now, is it different from the on paper, or in which the above two surfaces do find the earthworm is able to move easily? The body of an earthworm is made up of many rings joined end to end. An earthworm does not have a bones, it has a muscles which help to extend and shorten its body. During the movement, the earthworm is first extend the front part of its body, keeping the rear portions fixed to the ground. Then it fixes the front end and release the rear one. That's how it does its movement. In short, it then shortens the body and pulls the rear end forward. This makes it move forward by a small distance, repeating muscles expansion and contractions. The earthworm can move through the soil. Its body secretes a slimy substance to help them move. How does it fix a part of its body to the ground? Under its body, it has a large number of tiny bristles, a hair-like structure that projecting out. The bristles are connected with the muscles, and the bristles help to get a good grip on the ground. The earthworm actually eats its way through the soil. Its body then throws away the undigested part of the material that it eats. This activity of an earthworm makes the soil more useful for the plant, and that's why they are known as the farmer's friend. Snail. And observe a snail in your garden or in the field. Have you seen the round structure it carries on its back? This is called the shell, and it is the outer skeleton of the snail, but is not made of bone. The shell is a single unit and does not help in the moving from place to place. It has to be dragged along. Place the snail on a glass plate and watch it. When it starts moving, carefully lift the glass plate along with the snail over your head and observe its movement from the beneath. A thick structure and a head of the snail may come out of an opening in the shell. The thick structure is its foot, made of strong muscles. Now carefully tilt the glass plate. The way motion of the foot can be seen. Is the movement of a snail slow or fast compared to any earthworm? You can compare them. Comes cockroach. Observe the cockroach. Cockroach walk, climb, as well as fly in the air. They have 3 pairs of legs. This helps in walking. The body is covered with a hard outer skeleton. This outer skeleton is made of numbers of plates joined together, and that permits movement. There are 2 pairs of wings attached to the body behind head. The cockroaches have distinct muscles. Those near the leg move the legs for walking. The body muscles move the wings when the cockroaches fly. Birds fly in the air and walk on the ground. Some birds, like ducks and swans, also swim in water. The birds can fly because their bodies are well suited for flying. Their bones are hollow and light. The bones of the hind limbs are typical for walking and perching. The bony parts of the forelimbs are modified as a wing. The shoulder bones are strong. The breast bones are modified to hold muscles of flight, which are used to move the wings up and down, and that's how the bird flies. Fish. Make a paper boat, put it in the water, and push it in the one narrow and pointing forward. Did it go into the water easily? Now hold the boat sideways and push it into the water from the broadside. Are you able to make the boat move in the water? Not really, right? So, you have noticed that the shape of a bird is somewhat like a fish. The head and the tail of the fish are smaller than the middle portion of the body. The body tapers both ends. This body shape is called a streamline. The shape is such that water can follow around it easily and allow the fish to move in water. The skeleton of this fish is covered with strong muscles. During swimming, muscles make the front part of body curve to one side and the tail part swing towards the opposite side. The fish forms a curve as shown in figure 8.24. Then quickly the body and the tail curve to the other side. This makes a jerk and pushes the body forward. A series of such jerks make the fish swim ahead. This is helped by the fins of tail. Fish also have the fins on their body, which mainly help to keep the balance of the body and to keep directions while swimming. Did you ever notice that under the water divers wear feet like a flippers on their feet to help them move easily in the water? How do snake moves? Have you seen the snake slithers? Does it move straight? Snakes have a long backbone. They have many thin muscles. They are connected to each other even though they are far from each other. Muscles also interconnected the backbone, ribs and skin. The snake's body goes into many loops. Each loop, snake uses its forward push by pressing against the ground. Since it is a long body makes many loops and each loop gives this push, the snake moves forward very fast and not in the straight line. We have learned about the use of bones and muscles for the movement of the different animals. Haley and Bujo have many questions in their sex about the different movement in the animals. So must you be having unanswered questioning buzzing in your head? The ancient Greek philosopher Aristotle in his book Guide of Animals asked himself this question: why do different animals have their different body parts that they do have, and how do these body parts help animals to move the way they do? What are the similarities and differences in these body parts between different animals? How many body parts are needed by the different animals for moving from place to place? Why 2 legs for the human and 4 for the cows and buffaloes? Many animals seems to be having an even numbers of legs. Why is the bending of our legs different from the other our arms? So many questions. Perhaps we have looked for some answers through our activities in this chapter, and we need to look for many more answers in the future. That's the end of the chapter.